This is Chemistry 2, Chapter 9.3. There are 3 parts to this chapter: percent composition, empirical formula, and molecular formula. So today is percent composition. It is just some example problems. Make sure you try them yourself. So what is percent composition? Percent composition, which can also be abbreviated PC or the percent sign, comp, it's basically used to identify the percentage of each element in a compound. So for example, say you have potassium chlorate, which is capital C or capital K, capital ClO3, KClO3. Say you want to use potassium chlorate as a source of oxygen. That's fine, you can do that, there's oxygen present. However, you're going to want to know the amount or the percentage of oxygen in that compound. If you're looking for a certain percentage of oxygen that you need from this source, you need to be able to know if this is a good source to use or not. So percent composition is equal to the atomic mass of one element in 1 mole of that compound divided by the molar mass of the compound times 100. It sounds complicated, it's not. The good news is there is no stoichiometry or balancing of equations. So you're going to break from that for a little bit. The unit for percent composition is just the percent sign. So example 1, find the percent composition of each element in this compound, copper sulfide. So I've broken it down to 3 steps for you just so you get the hang of it. Step 1 is to determine the atomic mass of each element in its proper quantity. So this is kind of throwing it back to Chem 1. So you have to break apart the compound into its parts. So we have 1 copper and 2 sulfur. Okay, now you need to look at your periodic table and look at the atomic mass. So in your periodic table, the box for copper, and you don't want to round. I know we've been rounding a lot. This is not the time to round. So go 2 decimals. So copper is about 63. Let me move my computer here. 63.55 grams atomic mass. And 1 sulfur is about 32.07 grams. Okay? If I take my 1 copper times its atomic mass, I get the same number. And then I have 2 sulfurs times the mass of 1, I get 64.14. So like I said, try not to round your atomic masses. I know we've been doing that for a while, but you want to go 2 decimals. All right, so that's step 1. To determine the atomic mass of each element in this compound. So you have to use the subscripts. Second is determine the molar mass. Well, the good news is you already did most of the work. Now you just have to add these together. So 63.55 plus 64.14 is the molar mass of the compound. You should be used to that because you were doing that for stoichiometry, the molar mass of the unknown and the known. Watch that though, because that is something that's very easy to mistake. Make sure you check your math. So I add those together and I get 127.69, like I said, 2 decimals if you can, grams over moles, molar mass. Okay? The last step is to determine the percent composition for each element. So each element, we've got copper and we've got sulfur. Okay, the subscripts don't matter in this case. You take the mass of the element per mole divided by the atomic or the molar mass. So we said that copper in this compound had a mass of 63.55. And then you need to look at the molar mass of the entire compound. So divided by 127.69. We're trying to figure out how much copper makes up this compound. And then times 100. So you do that math. Once again, 2 decimals is good. I get 49.5 49.77%. So copper makes up 49.77% of this compound. Do the same thing for sulfur. So now we're looking at the entire mass of sulfur in the compound, not just one sulfur, however many there are, in this case 2. So I've got 64.14 divided again by the molar mass of the entire compound times 100, and I get about 50.23%. So pretty even, about half and half. So that's why you can't just say, well, there's 1 copper and 2 sulfur, so sulfur must be present in more abundance. You actually have to do the percent composition. So we've got about 49.77% copper to about 50.23% sulfur. That is finding percent composition of each element within the compound. All right, try example 2. Find the percent composition of each element in this compound, H2SO4. So once again, you have to do the same thing first. See how many of each element you have. I've got 2 hydrogen, 1 sulfur, and 4 oxygen. Looking at my periodic table, 1 hydrogen is about 1.01, 1 sulfur is about 32.07, and 1 oxygen is about 15.99. Now granted, if you use 16 there, not as precise, your number is going to be a little bit different than mine. I would accept it, but like I said, try not to round, which is hard to do since we've been rounding for so long. All right, so the total mass of hydrogen is 2.02 grams. Total mass of sulfur is 32.07, and the total mass of oxygen is 63.96. Step 1. Step 2, find the molar mass of the compound. So once again, add these together. That's going to be the molar mass. So I add them together and I get about 98.05 grams over moles. Technically, these are in grams if you want to be accurate. Okay, and then determine the percent composition for each. So I'm looking at how much of this compound is hydrogen, how much of this compound is sulfur, how much of this compound is oxygen. So I take the atomic mass for all the elements for that atom. So all total mass of all the atoms of that element. So hydrogen, I've got 2.02. For sulfur, I have 32.07. And for oxygen, I have 63.96. And I divide all of those by the compound's molar mass. And then you take that number times 100. Okay, so I get my my percent composition for hydrogen is about 2.06%. I have my percent of sulfur being about 32.71%. And it would be helpful if you box these, especially if you're squishing it like I am. And I found my percent oxygen to be 65.23. Okay. Let's try one more regular example and then we'll move on to just something a little bit different. Okay. Determine the percent composition for each element in the compound calcium hydroxide, which is CaOH2. Remember, you have to distribute this 2 to everything inside the parentheses. So I have 1 calcium, 2 oxygen, and 2 hydrogen. Atomic mass for calcium is about 40.08. Easy math there. Oxygen, about 15.99. And if you want to use all the decimals, by all means go for it. That's even more precise, but try to at least choose 2. And then hydrogen. Okay, so step 1 done. Step 2, add together to get the molar mass of the compound. I get about 74.08, and molar mass is grams over mole. And then once again, determine the percent composition for each. So I have calcium, I have oxygen, and then I'll do hydrogen up here just to save myself a little bit of room. All right, so using the atomic mass for all the calciums, there's only 1, over the molar mass times 100. Oxygen, there's 2 of them, so that's 31.98 over the molar mass times 100. And then hydrogen, there were 2 over the molar mass times 100. So the percent calcium, I get about 54.1. Technically 10, but zeros are insignificant at the end. Oxygen, I get about 43.17. And hydrogen, I get about 2.73. So like I said, 3 steps for finding percent composition. Find the atomic mass of each element and its quantity per atom. Find the molar mass of the compound, divide the 2, and multiply by 100. When you add these up, you should get right on the dot of 100, or very, very, very close to 100, under 0.00 something. If not, you did something wrong. All right, let's switch it up a little bit. Let's try this. I lied. You can try that one on your own. A little bit long, a little bit more complex. Just remember that you have to distribute the 2. You have to distribute the 2 to the H, and you have to distribute the 2 to the N. So try that one on your own. See if you get N is about 9.24%, H 2.66, PB 68.32, carbon 3.96, and oxygen 15.82. So try that out yourself. Actually try it. I know you're at home, so there's no guarantee I can see you doing this, but actually try it. If you can do that one, that's the most complex it can get. All right, now let's switch it up. Here's how we could actually use this, like I said before. You want to know which of these compounds that you have access to is going to give you the highest percentage of oxygen. You want oxygen. Which one can you use for your main oxygen source? So it seems like a lot of work, but it actually isn't. Okay, so I'm going to split my screen into 3, maybe if it lets me. That's uneven, but we'll make it work. So I've got H2O, which is water, H2O2, which is hydrogen peroxide, and CO2, carbon dioxide. Okay, I want to know which one of these has the greatest amount of oxygen. So I still need to look at the molar mass. So I still need to find the whole thing out. So 2 H's, 1 O. For this one, 2 H's, 2 O's. And for this one, 1 C, 2 O's. According to the periodic table, there's my hydrogen and oxygen. Once again, hydrogen, oxygen. And then in this case, carbon, which is about 12.01, and oxygen. Okay, so you need to add those together. And you can write out, like, equals. That's not going to hurt. I just am trying to move through this a little quicker so you get the hint of it. All right, so my total mass for this one using these numbers is 18.01 grams over moles. For hydrogen peroxide, it's about 34 grams over moles. And carbon dioxide, 43.99 grams over moles. So you have to have those right. We're just going to throw the rest off. Okay, I only want to know, going back to the problem, the highest percent of, sorry, I keep switching it by accident, of oxygen. So when I'm doing the division, the actual percent composition work, I only need to look at oxygen. So that makes it a little bit simpler than before. So it looks like you're doing 3 full problems, but you're really only looking at the oxygen. So I have 1 oxygen at 15.99 divided by the molar mass times 100. In this case, I had 2 oxygens. So 2 times 15.99 gives me 31.98. So make sure you do that math. Divided by this molar mass of 34. And then once again, I had 2 oxygens, so that's going to be 31.98 divided by CO2's molar mass. Okay, so do that math. I get about 88.78%. For H2O2, I get about 94.06%. And for carbon dioxide, I get about 72.7%. So which compound has the highest percentage of oxygen? It is hydrogen peroxide. So it has nothing to do with the subscript because there's a 2 here and a 2 here. You have to figure it out mathematically. So if I had only these 3 to choose from and I needed the highest percentage of oxygen to survive or to make something, I could use hydrogen peroxide as an oxygen source. All right, try a similar one. So in this case, you're wanting to find the percentage of chlorine. So once again, you have to break it down. Remember, this is chlorine, not capital C and then an I. An I would have a top and a bottom on it like that. Okay. Whoops. So once again, you have to look at this individually. 1 H, 1 Cl, 3 oxygens, 1 calcium, 2 chlorine, 1 manganese, 2 chlorine. Also watch that you're using the correct element. Don't mix it up. Okay, H, Cl, and O. Like I said, if you want to do equals right there, go for it. And then calcium. Manganese. Make sure you're using manganese, not magnesium. Okay, add those together for your atomic molar mass. Units are still important. Okay, so there's my atomic masses. Now I have to do the percent composition. So I have 1 chlorine divided by the molar mass of the compound, HClO3 times 100. In this case, I have 2 chlorine, so 2 times 35.45 gives me about 70.9. So that's where I got that number from, this math. Like I said, if you just want to keep writing it out, you're going to need it eventually. And then once again, 2 chlorine. And remember, this is the atomic mass, which I solved here by adding together. Did I say atomic mass? This is the molar mass, by adding together all the atomic masses of all the elements in their specific quantities. Okay, so I'm looking for the highest amount of chlorine. In this case, I got 41.99% chlorine. I got 63.89% chlorine for calcium chloride. And manganese chloride, I got 56.63. So looking at this, obviously, highest number, calcium chloride is going to be the best source of chlorine out of the 3. Okay, last but not least, different setup. What is the lowest amount or percentage of potassium? Okay, so try this one on your own. I will tell you that your answer should be this, but actually try it yourself. So, should be able to do the practice worksheet, or I'm sorry, it's not a practice worksheet, it's an actual worksheet. It is graded for completion and correctness. So it's exactly the same as what you've been doing. So once you watch this and try those problems, you should be able to complete that worksheet, the percent composition worksheet, without any issues and turn it in tonight by midnight. Chat me with any questions, and then tomorrow we will move on to the next part, which is the empirical formula.